This presentation provides an overview of Chapter 6, Part B, in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources. Edited by Aman Hakiki and Thomas Hurdle, and published by Springer. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover a portion of Chapter 6, which is on benchmark data, integrating biophysical and economic information in a consistent geospatial dataset. Previous chapters laid the groundwork by providing essential theoretical foundations and general conditions for a quantitative geospatial economic model, and by specifying the mathematical equations. In this chapter, we'll focus on the data requirements for this type of analysis. While Simple G is a multi-scale equilibrium model, it relies heavily on geospatial economic and biophysical information. The biophysical gridded information we need includes crop yields, represented in corn equivalent tons per hectare per year, land area, measured in hectares, water withdrawals, measured in cubic meters per hectare per year, as well as fertilizer use, quantified in kilograms per hectare per year. In addition, we also need economic information that includes the value of crops, measured in total sales in US dollars per ton, the value of land in US dollars per hectare, the value of water measured in total irrigation water cost in US dollars per cubic meter, as well as the cost of other inputs, measured by the total cost in US dollars per grid cell. The flowchart you see on this slide shows some of the main input datasets used in creating the Simple G database for the United States. The green highlighted data are parameters discussed in Chapter 7 of this book. Usually, we need to separate gridded information for irrigated and rain-fed crop production, which allows for better analysis of stress on water resources, as well as resilience to climate change. There are three types of gridded data. The first is based on observations like satellite-based land cover data. The second is data based on simulations from other models, like gridded water withdrawals. And third is the data that we have to estimate or generate based on other gridded and non-gridded data, such as gridded cost shares for irrigated production, or the gridded value of water. We also use county-level data in the United States from surveys, or from the Census of Agriculture from the USDA and USGS. For the United States, cropland area data was obtained from the USDA cropland data layer at a resolution of 30 meters and aggregated to 5 arc minutes. Irrigated cropland data was obtained from the moderate resolution imaging spectroradiometer irrigated agriculture dataset for the United States, provided by the USGS, at a resolution of 250 meters. Aggregated crop output for each grid cell is recorded as the corn equivalent total crop output. We take the value of crops sold per acre by county from USDA, and then use simulated yields from the Global Crop Water Model, or GCWM, to generate the gridded yield for the grid cells in each county. The GCWM data is aggregated over all crops using USDA and FAO prices to calculate the corn equivalent crop output for each grid cell. If you're interested in learning more about this topic, please review Chapter 6 of the Simple G book, where you'll learn how the value of water is calculated, how the corn equivalent yield is measured, and where the water quantity variables in the model come from. Here, you'll find additional readings and references you might be interested in further exploring. On this slide, you'll find the link to the Simple G webpage where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the Simple G book, Chapter 6b. We encourage you to explore the other companion videos that accompany the book on the Simple G webpage.